Okay, in this video we're going to cover the material in chapter 4, and it's 4.1 to 4.3. So it's all about multiplication. So we start out talking about interpretations of multiplication, and the definition of multiplication is when you multiply a factor times another factor and the result is a product. Okay, so here's an example of that. So 3 and 4 are numbers, which are also factors. So to get the product, which is your answer, you will multiply 3 times 4 and get 12. So by definition, the first factor stands for the number of groups. Okay, so the 3 would be the number of groups. And the second factor, by definition, stands for the number of objects in each group. Okay, and notice that as you go through math, this is relaxed in later years, but it does serve as a good model. So, for example, if I had 3 buckets, so the number of groups would be 3, and if I had 50 marbles in each bucket, then my product would end up being 3 groups with 50 in each group, so 150, in this case, it would be marbles. Okay, so let's go on to the next slide and we'll do the multiples. So when they talk about a multiple, by definition, a whole number b that is a whole number times another whole number a is called a multiple of a. So you get b by multiplying something, some number, by a. So for example, 20, that would be the b, is a multiple of 10, which would be the a, because 20 equals 2 times 10. So a whole number b that is a whole number times another whole number a is called a multiple. Okay, so down in this chart, I like this chart because it identifies multiples and factors, which are terms people get confused. So the product of a given number and another factor multiplied together is going to be a multiple. So 36 is the multiple and 4 and 6 are the factors. So to find the multiples of 4, you would multiply 4 times 1, 4 times 2, 4 times 3, etc., etc. So here is a list of multiples. Multiples are bigger. Okay, you multiply to make things bigger. 2 factors are multiplied together to get a product, and those 2 factors, for example, could be 1 and 32. You get the product of 32. 2 and 16, you get the product of 32. And 4 and 8 gives you 32. So again, 4 and 8 are the factors, and the multiple is 32. So at some point, we're going to talk about prime factorization. So for right now, 2 ways to think about this. When can, I can't really read this little tiny print. So when can I multiply together factors to get my number product? So what can I multiply together? So these are the numbers. These are your factors. They get multiplied together, and this is your product. So you can see that there are more than 2 factors that make up 32. So the ones that are listed here, or all of them, is 1, 2, 4, 16, and 32. They're all factors of 32. Okay, so that gives you a little introduction to that. Then let me go back a little bit so I can see this other picture. Okay, so in this little box, they have some neat things. They have all the multiples of 1. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. Here are all the multiples of 2. So 2, 4, 6, 8, 10, 12, that would be skip counting. Here multiples of 3, multiples of 4, multiples of 5, and multiples of 6. So I really like this figure because it gives you a very nice visual representation of what multiples are. So what's inside the number are the multiples, and what the number itself is the first in the multiples. Okay, so that's also a factor. Okay, so that brings us to the bottom of this page. And the last thing they tell us is how to tell if a problem is solved by multiplication. So multiplication applies to situations that involve equal groups. And we'll talk about arrays on the next slide. Okay, so in this figure, this is, we're going to create equations from arrays. So they say write each array as an addition problem and then solve it. So we're going to do this all over to the side. I'm also going to ask you to write each array as a multiplication problem, just to reinforce that multiplication and addition can go hand in hand. So let's do the whole thing as addition first. So I'm going to always add the horizons, the horizontal lines. So for number 1, I would say 3 plus 3 plus 3, and that's going to give me 12. For number 2, I would say 1, 2, 3, 4, 5. So 5 plus 5 plus 5 plus 5, and that's going to give me 20. For number 3, 1, 2, 3, 4, 5, that's also 5 plus 5 plus 5, and that gives me 15. So I'm turning all these arrays into addition problems, and then I have 4 plus 4 plus 4 plus 4, so that's 1, 2, 3, 4, plus one more, plus 4, 1, 2, 3, 4, 5, and that's going to give me 20. And for the hearts, I have 4 plus 4 plus 4 plus 4, which gives me 16. And then for the crosses here, 1, 2, 3, 4, 5. 5 plus 5 gives me 10. For the triangles, 4 plus 4 gives me 8. And for the moons, 3, 1, 2, 3, 4, 5. I have 5 of them. 3 plus 3 plus 3 plus 3 plus 3 gives me 15. And that's how many hearts I have. Okay, so that's taking your problems and taking their arrays and making them addition problems. But since you have equal quantities, we can make it multiplication as well. So this is 2, this is 4, so 2 times 4 gives me 8, and that's my example, and that checks. Okay, so this is 3 times 3. That's going to be 9. And that should have checked had I done that correctly. So now that gives me an opportunity to change that answer when I double checked it. Okay, so I did 3 cubed, which was not what this is. Okay, so the next one is 1, 2, 3, 4, 5 times 1, 2, 3, 4. So 5 times 4 gives me 20, and that checks. 1, 2, 3, 4, 5. This is 5 times 3, which gives me 15. That checks. 1, 2, 3, 4, 1, 2, 3, 4, 5. 4 times 5 gives me 20, checks. 4 times 4, 16, check. 5 times 2 is 10, check. 4 times 2 is 8, checks. And 5 times 3 is 15. So addition and multiplication are partner functions, and you can see how you can relate the two and how you can use them to verify your answers. So I like the array problems. Kids love array problems because they can make arrays with all kinds of different shapes, different animals, food items. Arrays are definitely great when it comes to addition, and then they're great again when it comes to learning multiplication tables. So let's go on to the multiplicative comparison problem down below. Okay, the textbook ties in ordered pairs at this point because you have something that goes first and something that goes second. So it's kind of related to what we've done. However, you're not going to add the things that go first and second, and you're not going to multiply them. You are just going to list them. So initially they say, tell what point is located at each of the ordered pairs. So 5, 8, you will go over 5, so that's going to be your x. Go over 5, and then go up 8, and you're going to get to m. So that's going to be m. So we'll jump around a little bit. We'll do a couple in a row, and then we'll move on. Okay, the next one is 12, 2. Always go over first, so go to 12, and then count up 2 from there. That's going to be p. Okay, the next one is 8, 7. Go over 8, so I'm going over 8, and then go up 7. So 8, 7 is going to give you h. Okay, the next one, 12, 10. Go over 12, and then go up 10, and that's going to give me g. So 7, 7, go over 7, and then go up 7, and that's going to give me q. And then go over 0, and then go up 10, and that's going to give me e. So make sure you're comfortable doing that. Ordered pairs go across first. So the order is across. Let me write that a little better. So go across, comma, up. Okay, that's the order for an ordered pair. Okay, so now they're going to give us the letter. You're going to locate the letter and then figure out what the pair is. So I can see where n is. I would go across 1 and up 1. I connect ordered pairs by a parenthesis, and by a parenthesis, and I put them in, by a comma, and I put them in parentheses. Okay, L, to find L, I'm going to go over 4 and up 3. To find J, I'm going to go over 11 and up 1. To find A, I'm going to go over 2 and up 12. So this is a very good exercise because this is something that the kids will always need to know, and if they don't practice it enough, they never actually own it, and it's always a point of confusion. Okay, so the next one looks like a B. So to find the B, I'm going to go over 0, or go up 0, go over 0, and then go up 4. And to find E, I'm going to go over 0 again and up 10. All right? Now the last thing it says, plot the following points on the coordinate grid. So let me erase all the things that I put on here so that you can see what I'm going to plot. Okay, so that's all nicely erased. Okay, if I want to figure out where 6, 11 is and put an S there, I go over 6 and then up 11. So that's this point right here. Whoops, 6, 11, right there. And I would label that with an S. Okay, 3, 5, go over 3, up 5, and that point will be a T. 9, 12 is U, go over 9, and then up 12. So 9, 12 is there, and that's going to be a U. So be familiar with this, know how to label things, and be comfortable instructing your students in this ordered pairs. Okay, so here the textbook's kind of jumping around a little bit, and it's going with the concept of pairings, and it's going to say that these pairings can lend themselves to tree diagram. So a tree diagram is a diagram consisting of line segments called branches. So here's the branch. Here's another branch. Okay? And the branches are connecting pieces of information. To read a tree diagram, you start over here. So start right here. And if I toss a coin, I have a 50% probability, or 0.5 chance of having an outcome of heads, and I have a 0.5 chance of having an outcome of tail. So on the branch itself is the probability, and the end word is the outcome. Okay, so the probability of each branch is written on the branch, and the outcome is written at the end of the branch. All right, so that's just a nice little activity. And then let's look at the 4C activity, because that's about pairing as well. So I want to go over that next. Okay, so I thought this was a very good activity. So the class activity 4C says the following. A bag contains 6 tiles labeled 1, 2, 3, 4, 5, 6. So we're instructed to reach into the bag, pick out a tile, and put it down. Then, without replacing the tile you picked first, reach into the bag again and pick out another tile, and then put it down to the right of your first tile. The 2 tiles side by side make a 2-digit number. Then put the tiles back in the bag. How many different 2-digit numbers can you possibly get this way? Notice that 4-2 is different from 2-4. So if you want to just go around and list possibilities, that's one way to understand how many possibilities you have. So for example, if we pick a 1, then my next number could be a 2, it could be a 3, it could be a 4, it could be a 5, it could be a 6. Okay, it can't be a 1 because I only have one of the 1s, and remember, I have not put it back in the bag. Okay, so let's do that again with 2s. If I pick a 2, my next number could be a 1. It can't be a 2, but it could be a 3, it could be a 4, it could be a 5, and it could be a 6. Okay, let's go with 3. I pick a 3, the next number could be a 1, it could be a 2, it can't be a 3, but it could be a 4, it could be a 5, it could be a 6. Okay, going to the 4, you pick a 4, you can then pick a 1, a 2, a 3, you can't pick a 4 again, but you can pick a 5 and you can pick a 6. Okay, continuing, you can have a 5, then you can pick a 1 next, 2 next, 3 next, 4 next, not 5, but 6. And then the last one, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. So how many possibilities do we have? So it looks like I have 1, 2, 3, 4, 5, 5, 10, 15, 20, 25, 30 possibilities just by counting them out. Now, notice something. They are saying that if I have a 1, 2, that's different than 2, 1. So are there any possibilities I have not considered? So think about this. The opposite of the reverse of 1, 4 is 4, 1. I have that taken care of. The reverse of 1, 5 is 5, 1. That's taken care of. The reverse of 1, 6 is 6, 1. That's taken care of. So I've counted all my possibilities. So that gives me 30. So you can do that. It's kind of labor intensive, but you can do it that way and get 30. Another way to do it is to do this. I'm going to have a 2-digit number. When I pick the first number, I have 6 possible numbers I can pick. 1, 2, 3, 4, 5, 6. I put 6. When I pick the second number without replacing the first one, I only have 5 possibilities. Guess what 6 times 5 is? It is 30, and that's a quicker way to count the possibilities. Okay? So that's kind of a neat problem. It says explain how to solve this tile pair problem. You can do it by either adding up all these possibilities or viewing them as an array and multiplying 1, 2, 3, 4, 5. So I would multiply 5 times 1, 2, 3, 4, 5, 6 and get 30 that way. Then I have the shortcut line method that also is very helpful. Okay, so in terms of how the definition of multiplication applies, I have 1, 2, 3, 4, 5, 6 columns with 5 numbers in each column. So 6 and 5 are factors, and 30 is the multiple. Okay, so that's how that applies. Okay, so we're going to do number 2 as well, because 2 is a slightly different type of problem, so I want to go over the approach for that. Okay, so let's read this example. It says a bag contains a red, a blue, a yellow, a green, and an orange, and a purple cube. Reach into the bag and pick out a pair of cubes, and then put the cubes back. How many different pairs of cubes can you possibly get this way? And they say, notice that blue-green is the same as green-blue. So that's what makes this problem different than the one we just had a second ago. You're not going to view things differently if the order is reversed. It's going to be the same 2 cubes. Okay, so the way I would handle this is I would say, okay, if I picked the red one, and what could I pick simultaneously with that? I can pick a blue, so I have red and yellow could come next, or red and green, red and orange, red and purple. Okay, so that's my pairing with the red. Then what if I pick a blue first? If I pick a blue first, what can the next one be? Well, it could be a red, but I've already counted that because I have a red-blue for my first selection over there. So how about blue-yellow? Yep, that works. How about blue-green? Yep, I haven't picked that yet. How about blue-orange? That's good. And blue-purple is good. Okay, so now go and pick another one. So what if I started out with the yellow in my hand first, and then I grabbed another one? Do I have yellow-red yet? No, I don't have that yet, because I don't have a red-yellow. Or do I? Yes, I do. It's right over here. So I can't use that one. So let's get rid of that one because that's not going to count. Okay, so then what else can I pick? So if I'm picking yellow, do I have yellow-blue? Oh, yes, I do. How about yellow-green? Nope, don't have yellow-green yet. Don't have yellow-orange yet. And don't have yellow-purple yet. Okay, let's go to the orange. Because I've already picked red, blues, yellows, and greens, the only ones I don't have are what? So I'm sorry, I should go to green next. So let me rephrase that. Let's go, I'm going to pick the green. Now, green, I could pick with orange, so I haven't picked that yet, and green can go with purple. All the other pairings I've already had. So that gives me the green. Okay, then I'm down to the orange. So I pick an orange first. I can only pair a purple with it and not double count. When I get to the purple, I already have purple located here, 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 and here. So I can't pick anything else. So now I'm going to add up these numbers. So notice that I don't have equal columns. So I can't really use multiplication. So the first column has 5 possibilities. The second one has 4. The next one has 3, followed by 2, followed by 1. So 5 plus 4 is 9. 9 and 3 more makes 12. Plus 2 is 14. Plus 1 more is 15. So 15 is the possible pairings I get this time. So notice I can't use my 5 times 6 line method because that will overcount. It overcounts because in this situation you do not view, for example, BY as being different from YB. Therefore you are eliminating half of your options. Okay? So explain how to solve this cube pair problem. If multiplication is involved in your explanation, explain how the definition of multiplication applies. So I would say addition is more involved this time because my columns are not the same. And in order to multiply, you'd have to have the same number of elements in each column. Okay, so we've already discussed 3. So in the cube pair, So in the cube pair, we said that RB is the same as BR. But in the tile pair, what we noticed was that 2,4 was not the same as 4,2. So we had 15 possibilities in the cube pair, and we had 30 possibilities in the tile pair. Okay, so then let's go to the next one, which talks about these little bears. Okay, so it says, how are the cube pair and the tile pair problems different from these bear pair problems? So the bear pair problem says you have 6 bears. If you put these bears in pairs all at one time, that's how it differs. How many pairs of bears will there be? All at one time, I have 3 pairs. Okay? So 1, 2, 3. I don't pick one at a time. I have to take care of it all at once. So that's why my answer is so much smaller. Okay, I took the 6 bears and I put them in pairs of 2 and got 3 sets of pairs. Okay, so I think this was a very good activity sheet. You may want to use some of this for your interactive notebook because it's very engaging and they're good thought problems. And you can actually create the little pieces and have the kids physically manipulate them to put them into the desired groups, because they would own it much better if they can have a hands-on demonstration. Okay, so in this section, it's 4.2, we're talking about base 10. So base 10 is how we count, and in general, we multiply a number by 10. All the digits move one place to the left because the value of each place is 10 times the value of the place to its right. So this is where place value comes in. So how do you find the product of 3 and 60 using base 10 blocks? Okay, so you would need to have another 6. I'm just going to make believe I have another 6 here. So each of these columns is worth 10. So if I have 6 of them, right, so I have 10, 20, 30, 40, 50, 60. So 6 columns of 10, you take your 6 and you move it one place to the left. That becomes 60. 6 times 10, you take your 6 that was in the 1's position and you move it to the 10's position. Okay, so I'm not saying you add a 0. I'm saying you move it to the next position to the left, which is the 10's position. You would do the same thing if I had another one here. 6 times 10, and that would be 6 in the 1's position times 10. You now move it so that it's in the 10's position. So then you can either add these up, 60 plus 60 plus 60, which is 180, or you can recognize that you have 3 groups of 60, and you can do the multiplication. Okay, now, so doing the multiplication, there are several ways to do it. I'm just doing it with this algorithm, okay? But there are other partial ways to do it, but that will get me the answer that I desire. Okay, I really like the next little patterned block, because it does show nicely how the 10s work. So let's look at that next. So this looks like a little embroiderer sampler. So it's kind of pleasing to the eye. It's cute, and it's a very nice summarizing tool. So let's look at the first equation that they have. And I'm calling it an equation because you have an equal sign. So it's an equation, not an expression. Okay, if you have 47.63 times 100, you're going to move your decimal point to make the number bigger 2 places to the right, and that's the resultant number. So you're moving this way. Okay, 47.63 times 10, just move your decimal 1 place to the right. 47.63 times 1, that's an identity. Okay, that's the identity property. and there's no change in your number. Okay, now this is 1/10. So when you multiply by 1/10, you're going to move your decimal one place to the left, making your number smaller. When you multiply by 1/100th, you're going to move your decimal places 2 to the left, making your number even smaller. And this is 1,000th, and move your decimal 3 to the left. You have to, in this situation, add a holding value so that you can actually move it. So you put the 0 there and then move one more place. Okay, so we had right movement getting bigger with numbers greater than 1. We had left movement getting smaller with numbers that are less than 1. Okay, here they're explaining what 10 squared is. So 10 to the power of 2 is 10 times 10, which will be 100. 10 to the power of 3 is 10 times 10 times 10, which is 1,000. And 10 to the power of 4 is 10,000. So this should be 10,000. Okay, notice the number of zeros match the power. If you have power 2, you have 2 zeros. Power 3, you have 3 zeros. Power 4, I have 4 zeros. Okay, all these patterns are important for your students and you to recognize because it makes math much more understandable. Okay, at the bottom of this page, I have 2 links for you to Khan Academy. Use Chrome to get there. Safari doesn't always get you to Khan Academy, but if you're not familiar with Khan Academy, click these links, and there's all kinds of very, very valuable material there for you to use. So Khan Academy is a terrific resource, not just for math, but for other subjects as well. Okay, in 4.3, they start talking about some of the properties of multiplication, and they tie it with areas of rectangles and volumes of boxes. Okay, so the commutative property of multiplication. I give you some examples here, but another example that I can talk through would be if you wanted to illustrate commutative property, you can say 2 times 10 is the same as, reverse the order, 10 times 2. Okay, that's your commutative property. Just reverse the order. It's kind of like commuting. You go this way to go into work, and you go this way to go back home. Okay, so another example would be 5 times 1 is equivalent to 1 times 5, and that equivalency demonstrates the commutative property. Okay, notice that when they do it with these squares, with these rectangle shapes that have squares inside of them, they are changing the direction of the array to illustrate the commutative property. So this is, first one is 2 times 5, and then you have 5 times 2. Okay, in any respect, you get 10 for your answer. I like the fact that they rotate the arrays by 90 degrees because it does give you a good visual of the commutative property. So let's look further down the page on the different formulas that they have presented for us. Okay, so here they are calling these fantastic formulas. So they are everyday formulas that your students should become familiar with. There are formulas that they'll use throughout their life in math and just throughout life in general. So perimeter means around. So you measure around the distance because peri, that prefix, means around. So when you see perimeter, you're going to go around. So let's say we start over here, and we're going to add 5 plus 5 plus 5 plus 5, and you'll get 20 inches that way. So notice when you just walk around and you add whatever units you have your individual figures in, that is the units in your final answer. Area instead is not the outside of a figure, but it's all of the inside. So you need your length, so we'll call this length and this width. So you need your length measurement times the width measurement. So 3 times 2 when you square the numbers, you get 6. When you multiply the numbers, you get 6. When you multiply the units, you get units squared. Okay, so if this was your carpeting, and say you had to carpet an area that was 10 feet by 8 feet, you would ask for 80 square feet of carpeting. Okay, so that's your area. Area is inside, perimeter is outside. Volume is always length times width times height. Okay, so if we say that this is your length, right here for the 3, that's your length, and the 2 is your width, and your height is 4, we would multiply those 3 numbers together. So 3 times 2 times 4, we would get 24, and then because we're saying meters times meters times meters again, that gives us cubic meters, or meters raised to the 3rd power. Okay, so these formulas are important to understand. They come up quite frequently, and you want to also definitely key in to the representation of the units. So perimeter, you have standard units. Area, you're going to have squared units. And volume, you'll have cubic units. Okay, let's go on to the next page of notes. Okay, so the next thing we're going to talk about is another property called the associative property of multiplication. So when you think about associative, think about associating numbers by using parentheses. So here you have your numbers just in a line. Here I'm associating 3 and 4. Here I'm associating 4 and 2. I get the same number for an answer, but I get it different ways. In the first way, when I associate 3 and 4, I get 24 by saying 12, do the parentheses first, times 2 is 24. On the right-hand side, doing the parentheses first, which is always key, you get 8 times 3, also 24. So you can use the property to multiply 3 or more numbers. If you change the grouping of the factors, the product will remain the same. Okay, so I just illustrated why this is true. So you can also do it by using arrays, and here's some examples of that here. The associative property also carries over to addition. So here's an example of addition, associative property. Here's an example of multiplication, associative property. Okay, here are some fun things to do in here. This is a nice little introduction to parentheses and the associative property, and it's kind of a cartoon, so check that out, see what you think. And this is a properties song to help you or your students remember the properties. And this is another activity that's marble estimation. See, these are all hyperlinks. If you click in here on the PDF that I've posted, you'll be able to see all these different activities and see what works for you, what you may want to use in your bag of tricks, or what doesn't work for you. Okay, the last thing we're going to do in this video is to talk about activity 4J, using multiplication to estimate how many. So let's do that on the next page. Okay, this first activity gives us a design on a roll of wrapping paper. So it's made by repeating the swatch below. So the wrapping paper itself is 40 inches wide by 50 feet long. Okay, so 40 inches wide by 50 feet long. So what we're going to do, let me just get the right page here so I can go over this with you, is we're going to say, okay, given that I have this, how can I model this? So what what you're going to do is you're going to say, okay, I'm going to measure this first. So you would take out your little ruler and you'd measure what they gave you on that form. So this is not to scale because I've enlarged it, but I'll write down those measurements in just a sec and we'll get going on that. Okay, so when I measured it, I got that this was 4 inches. So this was 4 inches, and this was 2 inches. Okay, So the actual thing that we're building is really 50 feet by 20 feet. Excuse me, 50 feet by 40 inches. Okay, so this is 40 inches. So think about this little sample that we have here as fitting right up here. So what will I need? Well, if that's going to be 50 feet, and if I have 4 inches for this one, then it's going to take 3 of these going across to make 1 foot, and I need 50 feet, so I'm going to have an array that's 150 of these samples across. Okay, so I'm not drawing my piece to scale. So then, on the same side, if this is 2 inches high, the little sample that I have, then I'm going to need 20 of those, right, to get 40 inches. So I basically have a 150 by 20 that I need to multiply. Okay, because that's how many I have of these little boxes that look like this sample. So the next thing I did was to count the number of stars. So in here, I counted them all, and I had 25 stars. So if there's 25 stars in every one of these sample swatches, and I need 150 across and 20 down, so I would say 150 times 20 times the 25 that I have in each one gives me a grand total of 75,000 stars. And that's how we would estimate how many stars are going to be in the entire roll of wrapping paper. Okay, so I thought that was kind of clever, and it's a nice way to use arrays as well. Okay, we'll do the next, the container problem on the next page so I can show you the whole container. Okay, so we're going to estimate this volume. So they're telling us that the container has a square base, so that all vertical sides of the container are identical. The picture shows one of these 4 sides. Use multiplication to determine approximately how many candies are in the container. Explain your method. So I counted the little gumballs, whatever they are, going across. So I said 1, 2, 3, 4, 5, 6. So I have 6 across, and then I counted up, and I counted the far side. So 1, 2, 3, 4, 5, 6, 7, 8. So I said this was 6 by 8, and since all of them are the same, so I'm going to have 4 of those, right? Because this is a 6 by 8, the back side is 6 by 8, and the way back and then the left side is all 6 by 8s. So I'm going to have 4 times 6 times 8 to get the volume. Okay, so is that true? No, that's not true. Let me think about this. Okay, let me back up a sec. Okay, what I want to say is this. This is going to be 6. So if you have this shape, okay, so it's really a prism, right? A rectangular prism. So if it's this shape and this and this and this, so the volume's going to be, and I'll continue to do this here, okay, so this is 6 by 6, and then how tall was it? It was 8 gumballs tall. So my volume is going to be 6 times 6 times 8, and that gives me about 288 gumballs if I approximate it that way. So see what you would do, and then check the answer in the back to see if that works for you. So that ends this lesson. So I hope that you enjoyed this. It's a lot of different ways to think about multiplication and addition. They're all very valuable. So go back through and make sure that it makes sense to you.